Good evening, my dear students. Engineering metallurgy unit number 3, the ferrous and non-ferrous material. So within this syllabus we have the one of the significant topic, that is age hardening treatment. So this age hardening treatment, it is normally we have idea about ferrous and non-ferrous material. Especially the non-ferrous material, it is subjected to the heat treatment process, that is improving the strength. So that is the main aim or objective of this topic. Now how we can achieving this kind of the strengthening mechanism through the heat treatment process. So initially, that is, we have idea about the aluminum alloys. So normally aluminum alloys, it is classified as wrought alloys as well as the cast alloys. So these wrought alloys is normally we have to n number of the from 1000 series to 8000 series. So in this series we have 2000 series and 6000 series, 7000 series. It is termed as heat treatable alloys. What is the meaning of the heat treatable alloys? Means this type of the material, while applying the external temperature or the apply the temperature, it is giving the meaningful end effects. That is the meaning of the heat treatable alloys. Now come to the topic, that is age hardening treatment. Now why we are, suppose for example, if you take it as the unit series, the 2000 series, it is termed as aluminum 96% and remaining 4% of the copper. Now this is the material, it is normally used as the rivet materials in the aircraft in the old ages, that is the old age of the aircraft's rivet materials, but it is replaced by now it is the welding process. But that is the significant of the meaning, that is the significant of the material, how we can improving the mechanical properties of the this aluminum alloy, especially the 2000 series duro aluminum. It is maybe it is termed as duro aluminum also. So the precipitation hardening, it is having the two steps normally, right? It is the first step, that is the solution heat treatment, and number 2 is the aging. So what is the meaning of this solution heat treatment means? So we have to first achieving the, for example, aluminum melting temperature is 660 degrees centigrade. So we have to improving the temperature, and above 660 means that the temperature, what will happen means all the solute atoms are dissolved and form a single phase of the solid solution, and this is the process, it is repeated by the quenching, that is a rapid quenching process, right? After that we have in the second step, it is aging. So this kind of the aging, it is giving a supersaturated solid solution, that is the meaning of is heated and intermediate temperature within the two phase region. At this temperature diffusion rate becomes appreciable. The precipitates of the second phase forms as finely dispersed particles. So now the step number 1, it is solution heat treatment. So this solution heat treatment, what it is involves means, first we have to reach the temperature above the melting temperature. That time what will happen, the solute atom, it is completely dissolved. Again we have to moving the rapid quenching process. So that process, what will happen, it is giving a that liquid is converted into the solid. Now again the step number 2, aging process. This aging process, it is giving a meaningful effect, right? So normally the aluminum and the copper, 96% of the aluminum and 4% of the copper, we have two improvement, that is the, it is second phase material, that is the meaning of the intermediate phase, that is the two phase region means, it is the meaning, that is the particles, fine particles, it is dispersed, that is Al2Cu, that is the meaning is Al2Cu. This is the fine particles, it is deposited in the output of the precipitation hardening process. Now that precipitation hardening, the precipitation hardening mechanism, right, we having the steps. What are the steps we having means, the first one is the solution treatment, number 2 is the quenching process, number 3 is the precipitation treatment. So these kind of the treatments, it is improving the mechanical properties. Normally we have to For example, if you take it as the 2000 series of the aluminium, it is maybe the ultimate tensile strength of the duro aluminum, it is more near to closely 320 megapascal, means while you have applying the this kind of the precipitation treatment means, so definitely can getting the more than 320 megapascal. That is the ultimate aim. We need to improving the mechanical properties like ultimate tensile strength, yield strength and elongation also. Now this is the a graph, it is indicating here the solution treatment, that is the indicating here, that is alpha plus, that is L, that is the meaning is it is indicated the it is pure liquid stage, almost this region, right, it is semi solid, that is alpha plus liquid, it is the semi solid, it is above the 660, it is completely dissolved, it is the solid completely, all the solid atoms are dissolved and it is giving a liquid state. Out at below the level of the 660 degree, what will happen means that is alpha plus L, it is the liquid, the alpha it is indicating the semi solid, the alpha it is indicating always the solid also. Now come to the point of the solution treatment, right, that is it is indicated by number 1. So this one, it is what it says mean, it is the treatment, it is beginning process, it is the beginning of the solution treatment. Again, what will happen means this, it is solution treatment process, it is reached, right, it is reached from the above 520 degrees centigrade, right. So from the 522 we have to drop the temperature, it is almost to the room temperature. The point number 2, it is indicating the quenching process, right. The point number 2, the circle, it is indicated the quenching process, the sudden quenching process, not a like a air cooling process, it's a sudden quenching process. After that, the step number 3, it is going to the age hardening, that is the age hardening process. The age hardening process, what it seems means, we have to keep the material in the furnace almost nearly 125 degrees centigrade at the temperature of 24 hour or 36 hours. It is depending upon the furnace capacity. So that is 24 to 36 hours we have to maintain the same temperature. Afterwards, what will happen means, just we can turn off the furnace and again just we can keep the furnace itself. So like the right side diagram, it is indicated the alpha and alpha theta. The theta means the theta, it is indicating the precipitates. The precipitates are it is formed or it is go and located where the material having the, it is in like a vacancy, right. The atoms, it is go and deposit where the atoms are, it is needed in that weak zones. The weak zones, it is identified and it is the precipitates, it's go and occupied the regions. So this is the mechanism. So the first one is the solution heat treatment, second one is the aging, that is the quenching process, and third one is the aging process. So effects of aging, temperature and time. See, this is the having the relationship to the yield strength and the aging time. So you have looking the graph, that is effects of aging, temperature and time. So while you have looking the close to the temperature around 400 to above 400 degree, that is GP2. What is the meaning of GP2? That is the grind boundaries are by the phase number 2. Almost the temperature, see, that is the aging temperature. Very carefully we have to look at it, that is 190 degrees centigrade. So it is varying. While you have varying the temperature of the aging process means, definitely what will happen means, that is the precipitates also it is improved, right. So we have to optimizing the level first. Then we have to looking the which one is having the, it's a trial and error. We have to identify it's a trial and error, but the almost the 2000 series 2024 already it is done almost. It is 125 degrees centigrade. but we have some graphs that is the indicated trial and error mechanisms. So the yield strength, and depending upon the temperature, it is the temperature and the aging time, it is deciding the yield strength. That is the main scenario for this kind of the graph, that is effects of aging, temperature and time. And this is the slide number 6, that is the aging curve. That is the aging curve. What is meaning of the aging curve? Means that is the aging time at the temperature and strength and hardness. That is the, so now the graph, it is slightly increases while having the aging temperature, it is increases means it is reaches maximum level, and again it is decreased, right? So the decreased means it is the meaning of the non-ferrous. What will happen means it is getting the over aging. That is, over aging means it is like it's a fault mechanism, right? We have to maintain a correct aging process, unless otherwise we have to face the problem. So the aging temperature and aging time, it is deciding the mechanical property. That is the main thing, it is indicating this strengthening curve. So again, this is the very main significant question. Most of the times, right, most of the times it is repeated in the universities, Anna University examinations. So don't forget, because before going to the preparation, just you can choose this topic, that is the age hardening mechanism or age hardening treatments, right? So all the best. Thank you.